Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about Titan is just plain weird, and we need to be okay with that, okay? And of course, taking listener questions about all things in this beautiful universe, because that's exactly what this show is about. We record every Thursday at 4 p.m. Eastern, so you can join the conversation by leaving a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about dialogues. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State. And for the next half hour, your agent to the stars. I got an exciting show for you today on Space Radio, where we talk about all things space, astronomy, astrophysics, rocketry. If it's above the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. That's right, you're in charge. Sort of. We record every Thursday at 4 p.m. Eastern, and today I am back in Studio A of WCBE Radio Columbus, so you can leave a voicemail on our website, spaceradioshow.com, any time of day, any time of year, anywhere in the world. Get those questions in, and you will run on the show. That's right, your voice on the show. How amazing is that? Mildly amazing is the answer. Get those questions in. We'll have a nice little conversation. You can also follow along with our Space Cadets tuning in live on YouTube and Twitch. You can join them tuning in from around the world, including but not limited to Scotland, Amsterdam, Salt Lake City, Eureka, California, London, Warsaw, Poland, Morgantown, West Virginia, and Louisiana, and Copenhagen, Denmark. Yes, you can be one of those illustrious Space Cadets. I'm going to take questions that you send there too. That's all. The links are on spaceradioshow.com. Seriously, folks, I've only prepped 4 minutes of show material. Actually, like even less. And I'm just going to make up the rest as we go. So let's get those questions in. Hey, Space Cadets. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And let's talk about Titan. Titan is the largest moon of Saturn. And, it's hard to vote for the weirdest planet or object in the solar system. Titan is right up there. Titan's bigger than Mercury, so it's bigger than some planets. It makes you question the definition of planet, but that's another show. And Titan has a really thick atmosphere. One of the thickest atmospheres, like for a small rocky world in the solar system. I think it's thicker than the Earth's, which is great. It has sand dunes. It has broad plains, as a little bit of cratered surfaces. It has lakes and rivers and streams as rain. But this is all operating at temperatures like a couple hundred degrees below zero. So these are not lakes and rivers and streams of water, because water tends to be frozen when it's cold like that. Instead, it's lakes and rivers and streams of methane. That's like the stuff you use to light other things on fire is just hanging out on Titan. And the sand dunes are sand dunes of like organic materials. It's not like sand, like sediment, like here on Earth. It's organic materials. And instead of rock, like here on the Earth, underneath our feet is rock, bedrock, rock. I can't think of a better word than rock, so we're just going to go with rock. On Titan, the quote unquote bedrock is ice. Because when you take water and freeze it to a couple hundred degrees below zero, it is rock hard. So it's like ice. It's rock, but made of ice. All right. And there was a new study by a team that were using the Cassini spacecraft data. Remember, Cassini spent over a decade in orbit around Saturn, studied Saturn and its moons, including Titan, including sending a probe down to the surface of Titan, the Huygens probe. Anyway, this team was using the data from that mission to try to map out where this water ice bedrock is, or where it's exposed. On Earth, where bedrock is exposed and where different kinds of rocks are in ground, dirt. You can tell I'm very much not a geologist. It tells you a lot about the history of the planet, the history of a particular region, what went on then. And so this team used very similar techniques to hunt for water ice. Like, where is water ice exposed? Where is it being covered up by sand, etc., or by lakes? And they found a corridor It's not like a canal. It's not a canyon. It's like a corridor stretching 4,000 miles long, which is longer than the United States. It's about 40% of the entire circumference of Titan. Right around the equator of Titan, there's this big belt of exposed water ice bedrock. And it's very strange because it doesn't map onto any other features. It's not like there's a big mountain chain there. It's not like there's a big valley in the same spot. It's just weird. Like, why is all this ice bedrock, ice rock? Is that what we call it now? Okay, ice rock. Why is ice rock exposed in this long band around the equator and not really anywhere else? I don't know. Do you know? Because I sure don't know. And these scientists didn't, the astronomers didn't know. They just reported the results and they said, we don't know either. Titan is weird. That's the latest and greatest when it comes to space. But it's time to answer some questions. Space cadets, you've got some good questions. Keep them coming. Next ski trip will be to Titan? Probably not. I don't think they have little chalets up over on Titan. Where are you gonna drink your hot chocolate? No, you're gonna have to ship it from Earth, and that's just not a thing. All right, I do have a voicemail question, so I'm gonna do that first for this segment, and then I'll hit all the Space Cadet questions. We've got a question here ready to go on Space Radio. And Greg, are you ready? Thumbs up. Play the tape.
What is the longest time a human has spent continuously in space?
What is the longest time a human has spent continuously in space? The record here goes to Valery Polyakov, who spent, I took notes. I listened to this ahead of time. Sorry, folks. Usually I just freewheel it. I actually listened to this voicemail ahead of time so I could take a note. If 438 days, that is over a year. That's like a year and a third up in space, non-stop. He was on the Mir space station from January of 1994 to March 1995. And let me tell you, when he got back to Earth, it really sucked. It was not fun at all. Like the human body is amazing. Except Greg's, it's mediocre. But on average, the human body is amazing and capable of all sorts of amazing feats. We're plastic. We can adapt to our environments. And when you go up in space, our body's like, hey, why do I need a big heart anymore? I don't need to fight gravity. I'm going to shrink that heart. I'm not going to waste any time or energy on a big heart. Or like, where are these bones? I don't have to stand up anymore. I'm just floating around. So let's get rid of those bones and these muscles. They're always having to walk around and lift things. Like, I don't need that anymore. So we're going to have some weaker muscles. So you atrophy. Now, over the course of decades of human spaceflight, we've come up with as many techniques as possible to fight this. So astronauts spend a good chunk of their day when they're in space exercising to try to fight, and they take special Captain America super serums or whatever to keep their muscles strong. But back in the 90s, this wasn't incredibly well known. So when Valerie came back, he was just like a puddle of goo. Like just like a blob, like a fleshy blob. And it took him a long, long time to recover to the Earth's gravity. Like, we're just so used to the Earth's gravity because our bodies, grew up in it, that we don't realize that how quickly our bodies will adapt to not being in this environment. And this poses a major, major problem for long-term space travel, because we don't know how long a human can last in space. Like, we're fighting it. We're trying to prevent the ill effects by the exercise and vitamins and eating lots of broccoli or whatever. I'm not, terribly aware of the details of human spaceflight here when it comes to this. We're doing our best, but still there's tons of health challenges that appear within days. And then the longer you spend in space, the worse it gets. There is a viable question here. There's a real question here that we simply don't know the answer to, which is, if you spend too long in space, can you even come back? What if your heart weakens so much and your muscles and your bones thin out so much that when you come back to Earth, it's just you just get squished down because now you're back in the giant gravity of the Earth? We honestly don't know. We honestly don't know because, it's kind of hard to run that experiment. The longest we've done is a year. Valerie did not have a good time when he came back. This poses even bigger questions if you're talking about sending people to the moon or Mars, or having colonists. Like, can humans even, can a baby fetus even grow a spine in no gravity? We don't know. Maybe gravity is required for us to have straight spines in the womb. I mean, come on, we don't know. And if you're born on Mars, for example, at 40% of Earth gravity, and you live your entire life on Mars, can you even come back to the Earth? Or are we just too strong? Like, imagine Earth's, you were born on the Earth, not hard to imagine because you have memories, but imagine you were born and raised on Earth, and then you went to, like, Jupiter and just tried to hang out. The gravity of Jupiter would squish you. If you're born and raised on Mars, you come to Earth, the gravity of Earth might just squish you like a little tiny bug. And this is posing massive health challenges, not just for returning to the Earth, but for staying in space, right? Because the longer you stay in space, the more these effects build up. It gets even worse, like your sinuses have trouble draining, which is going to be a big issue for me personally. You get extra blood pressure in your head and upper torso, and so this ends up squishing your eyeballs and you have vision problem. I mean, who asked for that? That was an unintended consequence of space travel. I mean, space is hard for a lot of reasons. And one of those is it makes your heart go away. How tragic is that? Thank you so much for the question. Don't forget, you can leave a voicemail anytime and join the conversation, or by joining the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. I'm Paul Sutter. This is Space Radio, and this show is brought to you by you. If you haven't done it yet, you really need to go to patreon.com/pmsutter to learn how you can keep this show going. Thank you so much for your support, and I'll see you after the break. Methanoids on Titan. That sounds like a cool TV show. Or should it be like Titan and the Methanoids? That's more of a band name. That's Oh, that's right. The Expanse TV series talks about, it has like some Martians coming back to Earth and they have to wear the special suits. Yeah, I remember that. I haven't watched season 3, so don't give me any spoilers. And if you're like, Paul, why haven't you seen season 3 of The Expanse? It's because I'm busy. All right, get off my back. All right, wow, tons. These are all today's? Wow, Nancy. Thank you. What do we got? What exactly is the great attractor? Is space travel worth it? AI versus humans. Ooh, great set of questions. Sterilio, there are 17 kinds of water ice. I believe the water ice on Titan is just normal ice. Ice 1. Or are we ice? Is normal ice 3? I forget which ice it is. Titan, as far as we can tell, Titan is just a legit moon of Saturn, Bob. Jared Gambrill? Oh, that's a good question. Man. Nancy is the best. I agree. Oh, season 3 of The Expanse is good? Good to know. I've watched the first episode. I just haven't. TV has been very low on my priority list. Maybe Greg and I should have a date. You want to go watch a sci-fi series like this weekend with me? Okay. Your girlfriend's not invited. It's just you and me. GNO, guys' night out. Man, so many questions. I'm not going to be able to get to those. Okay. I'll do a few and we'll see where we end up. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more Space Cadet questions lined up, more than I can answer, by the way, which is what makes this show so much fun to do. And you can also leave a voicemail. You can join the Space Cadets. Go to spaceradioshow.com for the links. But let's stop wasting time and let's start talking about time. We got a question here from Jared Gambrill on YouTube. If the light from a distant star takes 1,000,000 years of travel time for us to see it, how do we ever know if it still exists present day? We don't. It takes light from the sun 8 minutes to go from the surface to our eyeballs, which means if the sun were to blink out of existence in a moment, we wouldn't find out for 8 minutes. The sun could already be gone, and we wouldn't know for 8 minutes. Pick a random star in the sky. It could already be gone. We just won't find out. And you know what? I know that causes headaches and a lot of anxiety. You got to get over it because that's just the way the universe works. We got a question here from Root on YouTube. What exactly is the Great Attractor? So the Great Attractor, you may have heard, is not Greg. He's the minor attractor, but still attractive. It's still attracting, just like not greatly. Okay, that was not a diss, Greg. That was not a diss. It was kind of a compliment. Kind of. I could have said something worse because there's something else called the dipole repeller. I could have just went right there, but I didn't. I didn't go that far. Okay, Greg. Okay. Yeah. See. Yeah, he's gonna watch a TV show with me this weekend, right? Yeah. Anyway, the Great Attractor is. So when you examine the motion of the Milky Way galaxy is moving. We're moving in a particular direction at great speed, something like 600 kilometers per second, which in my book is pretty fast. And when we look at all of our neighboring galaxies like Andromeda and Triangulum, we're all headed towards something called the Virgo supercluster. And then us and the Virgo supercluster together are moving in a direction towards something we call the Great Attractor. The Great Attractor is a region in space where our local supercluster of galaxies are being gravitationally attracted to, where it's little groups of galaxies bundled together, then groups of galaxies bundled together to make clusters, and then clusters bundled together to make superclusters. So given enough time, this vast region of space, like 1,000,000,000 light years across, containing all these galaxies, they're all like getting glued together into this big region, the region we call the Great Attractor. There is a cluster at the center of the Great Attractor. It's called the Norma cluster, and it's a big one for sure. And given enough time, we'll all fall down onto it and form like a big giant ball of galaxies, except for the existence of dark energy, which is the accelerated expansion of the universe. Our motion towards the Great Attractor will eventually slow down, stop, and reverse. So we will never, ever reach the Great Attractor. In a few billion years, our motion towards it will stop, and then we'll start getting pulled away because of the accelerated expansion of the universe, and the Great Attractor will be no more. Another question Bob on YouTube is asking, is space travel worth it? Now, that's a juicy question, right? And it has to do with, space travel where, and for what purpose? If we're looking at this the lens of, say, stuff around our vicinity of the solar system, like the moon or Mars or the asteroid belt, and there is, some sort of commercial venture, like a single asteroid has more gold than has ever been mined in the history of the Earth or something ridiculous like that. Like, there's a lot of gold. And if there's a lot of gold, there's probably a lot of money because there's probably a lot of uses for that gold. Problem is, it's really, really expensive to get up there to that gold. You can't exactly just go prospecting and panhandling. No, panhandling's something else. The thing where you sift, whatever that's called, where you sift for little gold pieces in a river. Whatever that is, panning for gold? Whatever it is, you can't do that. You just have to go right to the asteroid, and the asteroid is really, really far away. And then you have to bring it all back, and all that takes fuel and energy and mass, and it's just ridiculously expensive. Someday in the future, perhaps not so distant future, there might be a decent economic case that, yeah, you'll end up making more money than you'll spend by going to get the gold or the platinum or whatever and bringing it back to Earth. For human exploration, there's a pretty decent argument to be made that humans are better than robots when it comes to exploring the solar system. We can pick things up, we can study them, we can turn them around a lot faster than a robot can. And so, you might have a good case there. When it comes to colonization, long-term habitation on the moon and Mars, that is going to be an expensive, tricky thing with a lot of challenges, a lot of engineering and human and social challenges. Not impossible. I want to be clear, it's not impossible for us to build like a colony on Mars. It's just really, really, really hard. And when it comes to anything outside the solar system or even the distant parts of the solar system, it's just like, where are you going to get all that energy, man? Stars are far away. It takes a lot of more energy than you think. Following up on that, we've got another question on YouTube from For No Reason. Love it. What are your thoughts on using AI versus humans and harvesting material from otherworldly bodies? So you can imagine a mining operation on some asteroid. Doubtful it's going to be people because people are expensive. People take a lot of resources. You have to take care of them and feed them and, and house them. You don't have to do that for a robot. Robot, you don't have to feed. You just got to give an energy source and it's kind of good to go. I'm imagining in the far future that any sort of mining operations within the solar system, it's going to be all robots all the time and probably artificially intelligent robots that are just doing their own thing without a lot of supervision. Following up on my earlier topic about going to Mars and living in space and all that, Cyrilli on YouTube is asking, could we perhaps get used to planets with higher gravity, maybe even if we weren't born there? Or maybe if we were born there. So yeah, you can survive. The human body can survive, couple G's tops, like, because we have like jet fighter pilots, we have those fair things, those rides that spin around really fast. You can get by in like 10 or 20% higher gravity. You could survive maybe in like twice as strong gravity. You're not going to have a good day or good life, but you could survive maybe. Anything past that, and it's just like you're just going to get squished. Gravity is just harsh, right? You just can't get around it. JB McCool over on Twitch is asking, is the local supercluster the same as the local group? So here we're getting into structures going back to the Great Attractor. So we live in the Milky Way galaxy. Us, Andromeda, Triangulum, and a few other galaxies are grouped together in something called the local group. How handy is that? The local group is falling into a nearby cluster called the Virgo cluster. There are a few other groups that are also in the vicinity that are also falling into the same cluster. Our Virgo cluster and a few other clusters are themselves grouped into something called the Virgo supercluster. And then there's also this Great Attractor, which is the center of a region that we call the Laniakea supercluster. And so there's these hierarchy of structures. Our local group, like I mentioned, we're never going to reach the Great Attractor. We're also never going to reach the Virgo supercluster. Or sorry, the Virgo cluster. We're never going to make it because dark energy will rip us away. Thank you for all those amazing questions. We're almost out of time today on Space Radio. But before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I recently wrote an article for Forbes talking about science communication, talking about what scientists can do. Like, it's this big question within the community of, wow, there's a lot of people who aren't so big fans of science and might even not like science. How do we talk to them? How do we win their hearts and minds? How can we get them to like science? Valid question. And so there's lots of sociology and psychology and educational models. And honestly, I think that the surest way to get someone to appreciate and understand and respect science is to understand and appreciate and respect them. I think that's the first step, is to one-on-one talk to someone as a human being, actually try to understand how they develop their views, where they're coming from, treat those views with respect and empathy, and create a dialogue from there, which is hard. I mean, this is just generally hard for like all humans to do. And I'm not pretending to be a saint up here on Space Radio. You're over here at WCBE Radio. Greg's the saint. He's a great guy. Super empathetic. See, I make sure at the end, Greg always comes out positive. You know, the compliments outweigh the detriments. I make sure. So it's a weird thing to talk to someone who like hates what you do, doesn't believe in what you do, thinks what you do is damaging, and to respect their views, to listen to try to understand where they're saying what they're saying and where they're coming from. That's a tough thing to do. But what else are you going to do? I mean, they're not going to listen to you if you start lecturing them. They're not going to start listening to you if you start browbeating them. They're certainly not going to listen to you if you tell them they're wrong. So how about listening to them first? How about really trying to understand? And then asking some important questions like, what are we really disagreeing about? Is there anything we can agree on? Can we agree on, a salad dressing? Can we start there? Do our disagreements really matter? Do they affect policy? Do they affect how, I would raise my kids or the world my kids will grow up in? If it doesn't really, really affect it, does it matter? These are important questions. I don't know the answers because it depends on every single person. But I think it's about creating dialogues and just one-on-one conversations and actually treating people like people. I know, ridiculous idea. I'm working on it too. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. If you haven't done it yet, you should do it. Patreon.com/PMSutter, Sutter, to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, Dan Mishalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. You can leave a voicemail, and you can get your voice on the air. You can also catch the live streams on YouTube and Twitch. Go to spaceradioshow.com for all those links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing and transmission. Thank you, Pavel. Hey, Greg, do you want to answer some of their questions? Yes.
Oh, this ought to be good.
This will be great. Because I couldn't get to them all. Let's see, you ready?
Sure.
All right. What would be the best scientific discovery or event that you would like to see next? Go.
Oh, I would like to see.
Take your time.
What is that? Now, I'm going to show you how not knowledgeable I am, but the probe that just left the solar system about a year ago. It's past our
Voyager.
Is that it?
Voyager
No.
or New Horizons?
I think it's
New Horizons did the Kuiper-Belt object.
Yes. What that will discover next?
Ooh,
Yeah.
I think it's done.
Oh, is it? What
think
about
so.
the Voyager then?
The Voyager, they're done too. They're just cruising. Sorry,
Can we
Greg.
send another one up and
Yeah, we only need $100 million.
write a check?
Patreon.com.
Write a check, Paul.
Okay,
sorry.
okay. I'll write a check for $100 million. It might or might not bounce. All right, you ready for another question?
Yes.
What's a good one? No, not that one. How will NASA deal with the time delay if they send a helicopter to Mars?
Oh, Lord.
Just how are they going to do it? Solve that problem, Greg.
Time delay.
Yeah, if they send a helicopter to Mars
Yeah.
and they got a remote.
Why would they want to send a helicopter to
Because why not?
Mars?
Okay, because NASA is run by 5-year-olds. who are Mars helicopter mission.
Who would want to man that mission? Would Paul Sutter want to man that mission?
I think it's gonna be remotely piloted. And that's the time delay problem.
That's so boring, though. Let's
Okay,
put
it is.
somebody in
You're
there.
right. You're right.
I don't
and
know.
There need to be
I don't know.
lasers. How near? This is Astro B. How near would another star have to come? This will be the last one.
All
The
right.
last Greg question. How near would another star have to come to the solar system to disturb the orbits of the planets?
Oh, Lord. They'd have to get right on it. No, it actually would not. I'd say some light years.
Some light years. Some light years is the answer. And that's how we're. Thank you so much, Space Kids. Thank you, Greg.
Yeah, whatever.
Yeah, whatever. See you next week.
Sorry, guys.